Welcome back, gearheads. Don't have a whole lot of time in my daily life to carry this on anymore, but a recent video released by Mopar Joe here on Facebook, or excuse me, on YouTube, created some questions, and I reached out to Joe to instruct him how to test different things when it comes to flat tappet failure. Now, this topic goes back 5 years ago, to the point where within the hot rod industry, those do-it-yourselfers building engines, they found out that flat tappets were failing, and there was all kinds of different reasons why individuals thought that that might be. It has come common practice that everybody building engines on their own to eliminate any kind of failure rate is just to automatically jump to hydraulic roller lifters. Now, I'm one of those individuals that you have to spend the extra money, hundreds of dollars more, to upgrade to a roller type system. But we have to understand a few things behind for those that are stuck in classes that require a flat tappet cam. Now realize camshafts have gone through multiple evolutions within their manufacturing. No matter what brand you're getting, so again, comp cams, Crane, Lunati, okay, it doesn't matter what brand camshaft you're getting. They're going to be ordered to the specs of what the company asked for. Realize there are warehouses full of hydraulic cast camshafts still being in use today that were manufactured back in the 2000s. Okay, now the quality of these cam cores has been all over the board. You will not be able to find a certain company where they get the top of the line cams. Okay, you're not going to find it. They will all share from the same core manufacturing. So today on the whiteboard, one of the things you can do to check your cam, and it's going to be very specific between your three American manufacturers, so whether it's Ford, Chrysler, Chevy, each engine block is designed, a little different, obviously. One area that I want you to pay attention to is between the Chrysler and the Chevy variation. Realize the rear plug, the frost plug of the Chrysler engines is actually, the frost plug is the same size as the core barrel. Okay, where the channel, the bore of the cam from front to back, the rear cam frost plug is the same size as the rear cam journal area. All right, even though it's a little bit smaller than the rest of them because it can only be installed from the front to the back, the rear cam bearing lobe is smaller in diameter. The rear cam frost plug is the same size. So depending on how deep you install your cam frost plug, whether you're driving in with a socket or a proprietary tool to drive that in, it can dictate how far forward or to the rear the cam actually sits within the cam position of the block. Now, the Chrysler is also rear main oily priority location. So the first place that receives pressurized oil is actually to the cam, okay, at the rear position. So depending on the RPM or the oil pressure level, introduces oil to the rear cam bearing area and in between the cam and the rear frost plug. Now, for any of you that have any cam laying around, doesn't matter what brand, for any Mopar engine whatsoever, I want you to look at the face of the cam, normally stamped with your manufactured part number. You're going to notice that it's been machined to the point where there's no machining marks in the face. It's going to be flush, and then obviously tool stamped to the part number or to the manufacturer name, even if it's laser etched. I want you to take the cam and look at the rear of the cam. Okay, is it flush, or do you still see the one directional machining marks? Okay, Your pre-2000 camshafts, if you see some old reconditioned or old stock cams out there, you're going to be able to tell what year manufacturing that came from without the part number telling you when it was actually manufactured. After approximately 2000, when some of the cam manufacturing was occurring overseas, the cams were actually cut in half or cut free of the blank, utilizing a stationary cam with a cutting wheel that comes through and cuts it one direction. So you're going to see machining marks that look like a half horseshoe. Okay, just a half moon. Like so. If you guys can see that. Easy enough. You can see that. Now the difference between the face of the rear of the cam to the front, where your timing chain gears actually be bolted on, the length of the cam might be different because of the finish, because the front of the cam was also cut off with the same process. But then they come back and follow up with additional process to make it smooth in order to stamp the manufacturing part numbers into it. Now these cutoffs, they're very crude, they're not precise, and it's not dictated by the entire length of the camshaft. Pre-2000 camshafts will have gone through the process of where they smooth both ends of the cam flush, making the cam core actually shorter. Okay, now with those earlier cams being shorter, when you install them at a center line of where the cam is going to sit once attached to the timing chain gear, the lobe profiles are going to shift and push the cam in one direction. Okay, obviously normally pushing towards the front of the actual engine block, towards the front of the vehicle once installed. They're not pushing the cam backwards. Now on the Chrysler, you have a retainer plate. And for any of you Chrysler fans out there, go ahead and look at the inside, the internal side of that plate. You'll see that there's a ring that provides an area for oil buildup. Realizing the front of the engine receives less oil pressure than the rear. So if you find a post 2000 camshaft with the machining marks, there's actually additional material to the rear of the cam. And if you're just pounding your rear frost plug into the galley, it could actually be forcing the camshaft to the front of the engine, exposing less of the cam lobes to the bottom face of the lifters. So if this is the cam lifter bore, the engine block, the cam lobe itself could be off one side or the other. So if you notice, if you're actually doing tests and following along within the, like Mopar Joe did, and you notice that lifters are actually turning counterclockwise instead of clockwise, you know that the lifter is making more contact towards the center and not towards the edge of the actual lobe. So your lobe profile, it's not doing what it's supposed to. The position of that lobe underneath the lobe bore can be altered. After 2000, I found that multiple cam manufacturers, because they're all using the same blanks, they may have two lobes that are machined off center from the rest of the entire cam core. It was stated in Mopar Joe's video, and it's something that I found many years ago. So what do you do to correct that? Again, you have to find the cam lobe positions directly under the center of the bores. And you can do that with a standard drill bit. You should be able to slide the drill bit chucks, or the flush ends of the drill bits, or any kind of round stock. You should be able to fit a 5/16 down the sides of the 904 lifter bore diameter, and it should fit equally on either side of the cam lobe itself. That way you know that the cam is centered exactly under the bore. Now, if you can do that all the way from front to back of all of the cam lifters and all of the lobes fit exactly there, leave the actual drill bit shanks inside those locations to keep the cam centered. Then drive in your rear frost plug. That is going to help close the gap between the frost plug and the back of the cam. Because remember, that's the highest oil pressure area within the oil supply system on a small block Chrysler. The small block Ford and small block Chevys have engine block material that are smaller than the cam, so you can't push the cam any farther back against anything, or there's no frost plug moving the or altering the location, lateral location of the cam within the engine block. So it's very specific to the Chryslers. There's a few solutions to this, obviously, by using the drill bit to center the cam lobes underneath the center of the cam or the lifter bores themselves, and then installing the pieces, or you can get threaded rear frost plugs. Okay, that way you can adjust it to the point where you have a very close tolerance between the plug and the rear of the cam. You can actually adjust the cam forward and back. Now remember, the Chrysler also has the front retaining plate. You don't want to have any binding causing the cam to be pinched between the retainer plate and the rear frost plug. You want approximately 12 thousandths clearance between the two. Now, if you look at the lifter bore and the cam lobe, that 12 thousandths, one way or the other, can dictate whether or not the lifter is riding on the portion of the lobe to where it will turn it clockwise in order to have a proper break-in and operation. If you are not willing to go through all these steps to check the cam lateral alignment within the engine block, skip it completely and go directly into a roller type cam design. If you're in a class restricting a flat tappet or a solid tappet design, you have to check everything. And after 2000, even solid flat tappet cams, you will find at least two lobes on the cam cores that will not line up perfectly zero underneath the lifter bores. After 2000, that's just the manufacturing process that occurred throughout the years. If you're finding old stock Mopar cams or even Hughes or Hughes cams prior to 2000, you probably have one that has been centered already, and each lobe is centered on the proper specifications for the small block Chrysler. The small block Chevy is going to have a larger variance of where the cam can move front and back without it exposing the lobe of the cam to the lifter. You're going to have less failure. Ford, because of their front retaining plate, normally rollerized of some sort, there's more variables added into the cam location. It will be able to expand more with the bearings, so on and so forth. And the block itself, the casting at the rear of the block, will limit how far back the cam core can actually move. So again, to remove any doubt with any kind of cam failure, everybody should be going rollerized. But if you're stuck with using a flat tappet cam, whether it's your budget or the class that you're in, make sure that you check everything. And if you're using a cam in that 2000 or 2002 newer that still has the machining marks in them, you have to check everything. Now, does that guarantee that your lifters are not going to fail? No, because after 2002, the lifters themselves may be remanufactured. They're Their crown and also the hardness of their lifters might be altered compared to the material of the cams. Period. After 2002, there's so many variables that you have to check. And if you are not a qualified machine shop, if you're a do-it-yourselfer that does not have all of the exact tools to test the metal composition or hardness of either the lifter, face, and the cam lobe itself, it's just basically a gamble of whether or not the engine is going to survive. Why take that chance? With the cost of everything nowadays, especially in the performance market, there's no reason to go flat tappet. The additional $400 or $500 more for a rollerized cam setup is only security to know that you're not going to be taking out an entire engine once it's running. Okay, that is a sales thing that you have to, if you're a machine shop, that you need to actually sell to your customers. Even $1,000 more for a roller design, that's $1,000 of security that your engine is actually going to function without failure within the first 5,000 miles of its life. That's what the quality of the industry has come to. You either have to check everything, you have to check all the manufacturing processes, even how they cut the cam cores apart and what material they might be leaving on the cams and how they fit into the blocks. Every single component has to be checked. You can't order a set of lifters and just throw them in and expect that they're going to run. You have to disassemble every single lifter and mic every component out to make sure that it's not remanufactured. Why has the industry come to that? When it comes to non-restricted cam designs, like the small block Chevy that does not have a retainer plate, your chain, as it wears out, the cam is also going to be able to move forward. If you're using a rollerized system, you realize most have to run a cam button. Okay, well, that cam button still needs to have room to be able to move. Depending on your cam cover, depending on the design and the stamping of that, it might create more room to the point where that button can actually just fall right out and drop down to the bottom. Or it could be to the point where if it's stamped with too much material in, you don't get that tri-finger with the center detent within the cam cover. It could actually force so much pressure on the cam button that it causes binding between the tin cam cover and the rear of the engine block itself, pinching the cam. And as cam chains wear out and start to get loose, the more movement that cam can move forward or back before it receives any kind of resistance from the chain itself. So again, there's all kinds of variables to be thrown into this. If you're a do-it-yourselfer, you're going to have to take the big bite and just go rollerized, or you're going to be facing multiple challenges and you have to mic out and measure every single thing. A reputable machine shop can even miss this. Okay, no matter how detailed they are, you can miss it. It's gotten to the point where even machine shops, if you tell them, oh, I want to run a flat tappet cam, they're going to charge you an additional $1,000 in the total invoice because of the additional steps and time it takes them to check all the components. So you're going to be paying $1,000 more no matter what you're going to do. Would you rather pay $1,000 more to your machine shop or your engine assembler, or would you just rather spend $1,000 getting a roller cam design? Okay, it's a horse apiece. Now, it's been a while since I created performance videos. There's obviously individuals out there right now that are trying to call me out or debunk some of the information we have. Folks, I'd rather stick with individuals that have been doing this for 50, 60 years. The individuals that are just getting into the industry now that are getting popular. Talk to the gentlemen that are over 60 years old. Show them the more modern stuff that you have. talk to your machine shops that have been in business for at least 40 years. At least. They're going to be in business and have that experience to show the pre-2000 to the after 2002 models of the cams. They're going to be able to notice that and identify it immediately. For machine shops that started after, say, 2004, 2005, they're only aware of what's been on the market. The high manufactured cam cores that are nowhere near the quality of what they were before. It's that simple. So even a reputable machine shop, it's not just their reputation, it's when they received that experience. Pre-2000 or after 2000. Luckily, when I was in the machine shop business, I was taught by the individuals that were around prior to 2000. I was thrown into the mix as a business owner, as a machine shop operator in 2005, and I immediately started seeing the problems. It took me about a year to figure it out. Okay? It took me about a year to identify and start seeing the mismatched components coming from different manufacturers. And it just so happened to be that year I was working with Competition Cams. I had a contract with them. I then started switching over to Lunati or Iski and so on and so forth to avoid some of the issues that we've seen on the Competition Cams. But then eventually by 2005, all of the manufacturers were using the same low quality cam cores. Okay, so we can't point fingers at just one company. All right, it'd be unfair. So again, you can still find quality ones out there. Make sure that if you're utilizing machine shop, that they have something on hand. Maybe they have a stock of cams already ready for reassembly that they have checked through. It might save you a few dollars. Ask them. You never know. Just thinking of recent issues that come up in videos I've been watching. Obviously, I'm still following along with Uncle Tony's Garage. I don't necessarily follow along with his motorcycle type content, but what he has been covering with intakes, heat exposure, as far as the intake system, he's been spot on. The latest video I seen with the clutch packs, spot on. So it's been fairly interesting. And again, there you go again, folks. There's somebody that was in the performance industry in the 70s and 80s to the point where he has identified what's changed. The advancements in technology, where we started finding the problems and issues in approximately that 2000 year area. Utilizing old components, it's getting harder and harder to find them. It's getting more and more expensive. The used parts era from pre-2000, the prices are extremely high. You're paying for 1980s quality, if you can even find them. I have been following along with some of the Eric Weingartner videos, folks. The longer that I follow along with his dyno sessions or his flow bench tests, the more I scratch my head, just kind of. It might show improvements on the flow bench, but I'm still not completely convinced that his style of porting is necessarily the most beneficial in the final outcome. I'm also watching along with Spire YouTube content. While his techniques and his porting styles obviously work, okay, folks, they obviously work. He's altering the original equipment so far beyond the original design, they're not close to stock. They're covering it up. And for whatever reason, within the classes that he is building engines for, they're not checking this kind of stuff. Speaking of which, recently, one of the local legends here in central Wisconsin, Dick Trickle, is now being added to the short track Hall of Fame. In the multiple races, thousands of races that Dick Trickle was able to win, he was able to do so doing his own machine work and covering up, the stock components that was required by all the sanctioning bodies. And he was still able to outperform 90% of the field, the most winning short track driver of all time. Now, within Texas inspections on his equipment, it's gone to the point where if the ports were touched at all, if there was any machining marks whatsoever, it was an illegal build. That is how tight and specific the rules are with local short track racing and stock classes. You can't touch anything outside of regular machine work. It actually has to have machining marks to prove that it was done by a machine shop. There is no hand porting or massaging involved. If there was any kind of, whether it be scoping or disassembling the engines, if there was any doubt by the inspectors that it was machine shop done with tools over hand modifications, it immediately eliminated those engines or those components. So again, watching some of the Spire, some of the magic that he is doing with his epoxy and porting to cylinder heads, even to intakes, absolutely, that's going to create all kinds of additional power. But what sanctioning body allows those types of modifications, especially when they're obvious even from the outside? Even if they just crack off the intake, those engines would immediately be eliminated from the competition. Okay, so again, it really comes down to sanctioning bodies. How strict are they on the rules? If you're a do-it-yourselfer at home where you don't want to be spending all these times, keeping to the acronym, KISS, keep it simple, stupid. That is honestly going to be the best outcome for you. Spending the least amount of money, spending the least amount of time, just massaging things over. Now, speaking of which, one of the most recent Eric Weingartner videos, he was talking about port alignment. Okay. Intakes and cylinder head molding. Again, the same thing that we observed with the camshafts in approximately 2000 to 2002 era. You're going to see the exact same problems with intakes and cylinder head molding from that same era, newer. Okay, back in the 1980s, if you bolted on a intake onto a set of cylinder heads, the port alignment side to side would be spot on. Exact. The ports might be up or down depending on if the heads had any machining done to remove any kind of warping. Then your ports would be misaligned top to bottom, but never side to side. From 2002 on, if you are not getting the components cast by the same company where they bring stuff in and make sure everything lines up, if you're mixing, say, an Edelbrock with some trick flow cylinder heads, they are not going to align the same. They won't. So again, it comes down to, if you're going to stick with one manufacturer, if you're going to use trick flow heads, use the trick flow intake, unless you're willing to go through and do all of the hand modifications to get everything to work. It's that simple, folks. While we like to mismatch all the components that might perform the best on a test or within the sales pitch, think of all the additional time and money you have to stick in to make those components work together. That is the headache within the performance industry. It's good for machine shops, okay? It's more profitable for the suppliers. It's not geared towards the customer. The performance industry has found ways to make money in multiple different ways off the customer. Not just on the initial purchasing price, but within the machine shop, modifications, tools, so on and so forth from that point on. Get the truth out of the bait. So with that, Mopar Joel, I don't mind helping you out because you have been in the individuals that have not come out and, been rude. You're a nice gentleman. You obviously are trying to teach yourself as much as you possibly can. You are sharing that information to all of your subscribers. They should be appreciative of what you do. You're also showing the performance at the track. Okay, so Mopar Joe, you're an A in my book. Have a good one.